As student, my name is Professor Prakash Sir, author, Mathematics Part First and Second for Class 12, Engineering Mathematics First, Second, and Third for B First Year and Second Year for all branches. Welcome to my YouTube channel. Today, we solve multiple choice questions on applications of definite integration from mathematics part second. First multiple choice question is, here we find the area bounded by the curve. In the first multiple choice questions, we find the area bounded by the curve. The area in square units of the region. Here one curve is given and equations of the curve is y square greater than or equals to 2x and x square plus y square less than or equals to 4x, x greater than or equals to 0, y greater than or equals to 0 is option A, pi minus 4 root 2 by 3 square units, pi by 2 minus 2 root 2 upon 3, pi minus 4 by 3, option C. Option D, pi minus 8 by 3. In this problem, we find here the area bounded by the curve in square unit and equations of the two curve is given. First equations of the curve is y square is equals to 2x. And here y square is equals to 2x. This is the equations of the parabola open towards positive x direction with vertex at origin. And second equation, x square plus y square less than or equals to 4x. That is x square plus y square minus 4x, which is equals to 0. And this is the equations of the circle. And both these equations here, that is the equations of the parabola and equations of the circle, do not contain the constant term. Therefore, they passing through the origin. So first we find here the point of intersections of the curve. So first point of intersection is both these equations do not contain the constant term. Therefore, their curve passing through the origin. Therefore, first point of intersection is O00. And next we find again the second and third point of intersections of the given curve. So from these equations, y square is equals to 2x. So we put this y square is equals to 2x in the equations of the circle. So here x square plus, here put 2x. X square plus 2x minus 4x, which is equals to 0. Again, we repeat this. Y square is equals to 2x. Put y square is equals to 2x in the equations of the circle. So we get here x square plus, here put y square, that is 2x. So x square plus 2x minus 4x, which is equals to 0. Therefore, x square plus 2x minus 4x, that is x square minus 2x is equals to 0. From this x take common. X take common. So x is equals to x take common, x in bracket x minus 2 equals to 0. Therefore, x is equals to 0, x minus 2 equals to 0. Therefore, x is equals to 0, x is equals to 2. And if x is equals to 0, then y equals to 0. So we get here 0, 0 is the first point of intersection. If x is equals to 2, we put here x is equals to 2. 2 into 2, 4. So y square is equals to 4. Therefore, y is equals to plus minus 2. Y is equals to plus minus 2. Means if x is equals to 2, y is equals to plus minus 2, that is 2 comma 2 and again 2 comma minus 2. Means here the point of intersections of the given curve are 3. First is O00. Second, that is first is origin. Second is 2 comma 2. And third is 2 comma minus 2. And 2 comma 2 lie in the first quadrant. 2 comma minus 2 lie in the fourth quadrant. Therefore, here we write the point of intersections. The point of intersections of the given two curve, that is y square is equals to 2x and x square plus y square which is equals to 4x are here 0, 0, 2, 2 and 2 minus 2. So this is the origin. 2 to lie in the first quadrant, 2 minus 2, x coordinate positive, y coordinate negative, so lie in the fourth quadrant. Then we draw here the figure roughly. That is the first we draw here y square is equals to 4x and y square is equals to y square is equals to 2x. First we draw here y square is equals to 2x and y square equals to 2x, that is the parabola open towards positive x direction. And next we draw the circle passing through the origin. So this is our figure. This is our figure. This is the parabola. Y square is equals to 2x. And this is the circle x square plus y square, which is equals to 4x, or x square plus y square minus 4x, which is equals to 0. And we find here the area bounded by the curve in the first quadrant, because here x greater than 0, y greater than 0. So we find here the area bounded by the curve in first quadrant. So this shaded region is the area bounded by the curve, and we find this area. So therefore here this required area, this is the point of intersection, this is origin, O00, A point, that is 2, 2, lie in the first quadrant. Suppose this point is B point, and this is 2 minus 2, lie in the fourth quadrant. And then we find this area. So we find this area, that is the area of the here, this quadrant of the circle, area of the first quadrant of the circle minus this area, that is the area of the arc OBAO. यानी आपको क्या करना पड़ेगा, ये जो पहला क्वाड्रेंट है यहाँ पे सर्कल का, ये कंप्लीट एरिया है, इसमें से ये वाला एरिया सब्ट्रैक्ट करने का है, ये दैट इज OABO. We subtract this area from the first quadrant of the circle. So we know that the area of the complete circle, we know that the formula for finding out the area of the complete circle, that is pi r square, and area of one quadrant, here fourth quadrant are present, first quadrant, second quadrant, here third quadrant and fourth quadrant. So complete area of the circle divided by 4, we get the area of one quadrant of the circle. That is here pi r square. But here r, pi r square upon 4. This is the area of this first quadrant, pi r square upon 4. But here r is equals to 2. So pi 2 square by 4. And 2 square is 4. So 4 pi by 4. 4 cancel pi. Therefore, area of the quadrant, first quadrant is pi. Again, we repeat this. Area of complete circle is pi r square. Therefore, area of one quadrant of the circle is pi r square upon 4. But here r is, that is radius is this 2. So radius equals to 2. Therefore, here pi into r square means radius square. So 2 square, pi into 4 by 4. 4 get cancelled. So pi. So here pi minus area of this arc, that is OABO. So integrations here, integrations, x is equals to 0 to 2, x is equals to 0 to 2, and y of this parabola. So we know that y square is equals to 2x. Therefore, y of parabola root 2 into root x. Y of parabola root 2 into root x. Therefore, here the area of the arc OABO, which is equals to integration 0 to 2 root 2 into root x into dx. So we find here the required area, which is equals to area of one quadrant of the circle, pi r square by 4, but here radius is 2, so pi into 2 square by 4, minus here integration 0 to 2, here integration 0 to integration here x, that is integration lower limit x is equals to 0 to x is equals to 2, and y of this curve, this is a parabola. We know that y square is equals to 2x, therefore y is equals to root 2 into root x. So we write here root 2 into root x into dx. Then here 2 square, that is 4 get cancelled, so right here 5. Then we evaluate this. Root 2 constant, root x to the power half into dx. Use your formula integration x to the power n into dx, x to the power n plus 1 upon n plus 1. Similarly, x to the power half plus 1 upon half plus 1, that is x to the power 3 by 2 upon 3 by 2. And then we put here upper limit. And upper limit is here 2. So 2 to the power 3 by 2 upon 3 by 2. So 2 to the power 3 by 2, 2 into root 2. 2 into root 2 upon 3 by 2. That is 4 into root 2 upon 3. And 4 into root 2 into root 2, so we get 8 by 3. This minus sign here, we get here 8 by 3. If I put lower limit, then we get here 0. Therefore, our area of the shaded region is pi minus 8 by 3. Pi minus 8 by 3. So here, pi minus 8 by 3. Here D is the correct option. Here D is the correct options. So in this way, we solve the first multiple choice questions. In this multiple choice questions, we solve maximum step orally. Write some step, but we solve maximum step orally. So dear student, if you like my video, please subscribe my channel. Again, we request you, if you like my video, please subscribe my YouTube channel. Next, we solve second multiple choice question. And second multiple choice question is the area of the region bounded by the parabola y minus 2 whole square, which is equals to x minus 1. Again, this is the equations of the parabola with vertex at 1, 2. With vertex at 1, 2. Remember this. The tangent of the parabola at point 2, 3 and the x-axis is option A 6 square unit, option B 9 square unit, option C 12 square unit, option D 3 square unit. So here we find the area of the region bounded by the parabola y minus 2 whole square, which is equals to x minus 1. And this is the equations of the parabola with vertex at 1, 2. Remember this. Next, we find here the equations of the tangent to this parabola at the point 2, 3. And then we find the required area. So first we write here the given equations of the parabola. The given equations of the parabola is y minus 2 whole square, which is equals to x minus 1. This is the given equations of the parabola with vertex at 1, 2. So right here vertex 1, 2. And this parabola meets the x-axis at point 5, 0. That is here we find the point of intersections of the parabola and the x-axis. And on x-axis, we put y equals to 0 here. Then 0 minus 2 minus 2. Minus 2 square 4. So 4 is equals to x minus 1. Therefore, x is equals to 4 plus 1. Therefore, x is equals to 5. Means here x coordinate is 5. So 5, y coordinate is 0 because the point lie on the x-axis. And also these equations can be written as, by solve this bracket, then y square minus 4y, y square minus 4y plus 4 plus 1, here plus 5 minus x, which is equals to 0. And next we find here the equations of the tangent to this parabola at the point, is given here at the point 2, 3. We find here the equations of the tangent to the parabola at the point 2, 3. So first we find here the slope of the tangent to the parabola, and then we use the formula. We know that the parabola, if the tangent or if the line passing through the point x1, y1 having slope m is y minus y1 is equals to mx minus x1. We use this standard result and find out the equations of the tangent at the point 2, 3. So first we find here slope. So we find here the derivative of these equations of the parabola. So differentiate these equations with respect to x. Then here 2 ddx of y square 2y into dy by dx minus 4 dy by dx minus here 1 derivative of 5 0. So we write here in the next step here 2y into dy by dx minus 4 dy by dx minus 1 which is equals to 0. And here therefore from this we find here the dy by dx. Therefore here from this dy by dx take common here 1 upon 2y minus 4. To take common then 2 in bracket y minus 2. So dy by dx is equals to 1 upon 2 in bracket y minus 2. And we find the slope of the tangent at the point 2 comma 3. Therefore dy by dx at 2 comma 3. Here 1 upon 2. Here put 3 minus 2, that is 1. So 1 into 1 by 2. Here 1 by 2. And this is the slope of the tangent. This is the slope of the tangent. And next we write the equations of the tangent at the point 2 comma 3. So y minus y1, that is minus 3. Y minus 3 which is equals to 1 by 2. X minus x1, that is 2. X minus 2 means here y minus 3 which is equals to 1 by 2 in bracket x minus 2. So right here equation of tangent y minus 3 which is equals to 1 by 2 x minus 2. Then this can be written as after solving this we get here x minus 2y plus 4 equals to 0. This is the equations of the tangent to the parabola. And then we find here the required area bounded by the given parabola, tangent and the coordinate axis. So here we draw first the given parabola. We draw here the given parabola. This is the given parabola. And this is the tangent to the parabola at point P 2 comma 3. This point is given. This is the tangent to the parabola. And equations of this tangent is x minus 2y plus 4 equals to 0. Equation of that this tangent is x minus 2y. This is the equations of the tangent x minus 2y plus 4 equals to 0. Then we find here the point of intersections of the tangent and y-axis. So in the equations of the tangent, we put here x is equals to 0. On y-axis, we put x is equals to 0. So in these equations, we put x is equals to 0. So minus 2y is equals to minus 4. Therefore, y is equals to 2. Therefore, 0 comma 2. So right here 0 comma 2. Next, we find here the coordinate of the point of intersections of the given tangent and y-axis. On y-axis here, on x-axis here, x is equals to 0. Next, we find the point of intersections, coordinate of the point of intersections of the given tangent and the x-axis. So on x-axis, here y equals to 0. We put here y equals to 0. Then x is equals to minus 4. So right here, x is equals to minus 4. Next, we find here the point of intersections of the parabola and the positive directions of x-axis. Again on x-axis here, y equals to 0. So we put y is equals to 0 in the equations of the parabola. So here equations of the parabola is y minus 2 whole square which is equals to x minus 1. On x-axis y equals to 0. Here put 0, 0 minus 2, minus 2, minus 2 square. That is 4, 4 plus 1, 5, x is equals to 5. So right here 5 comma 0. 5 comma 0. And then we find here the area bounded by the curve, this tangent and the coordinate axis. So shaded region is the required area. We find this area. So first we find here the area of the triangle ABO. We find here the area of the triangle ABO. Area of triangle, again we repeat this, area of triangle ABO. We find this first. Next, we find here the area bounded by the y-axis and the curve. That is this area. We find this area here. So we find this area here. So area bounded by, first we find the area bounded by the, first we find here area bounded by the triangle. This triangle is OAB. And we know that the formula for finding out the area bounded by the uh, triangle is 1 by 2 base multiplied by height. And here base is here 4. Because the distance of the point B from the origin is here 4. Length is non-negative, so this is 4 and this is 2. So 1 by 2 base 4 multiplied by height 2, that is the y coordinate. So we write here 1 by 2 base 4 into 2 plus we find this area, and we find this area, that is here the area here bounded by this line, that is x-axis, and we know that the equations of the x-axis is y equals to 0. Next we draw PD perpendicular to y-axis, and equations of this PD is y is equals to 3. Therefore here integration y is equals to 0 to y is equals to 3, and x of this curve, x into dy. So if I find here x of this curve, means from these equations of the curve, we find here x. So from the equations of the curve, x is equals to, from this equation we find x, y minus 2 whole square plus 1. So we write here y minus 2 whole square plus 1 into dy, minus here we write x, y minus 2 whole square plus 1 into dy. This 2 get cancelled. So we write here 4. And here we find the area from this shaded region, that is the area of this region, we subtract the area of the triangle ADP. Area of the triangle ADP. Here minus 1 by 2 into 2 into 1. That is here. This base is 2. Base is here 2. And then we find this height, that is AD. Height AD is equals to, up to this OD is equals to 3 y coordinate. Because here D and P are collinear. So OD is equals to 3. 3 minus 2, that is 1. So here minus 1 by 2 into 2 into 1. So right here minus 1 by 2 into 2 into 1. Again we repeat this. First we find here the area of the triangle OAB. That is 1 by 2 base multiplied by height. So 1 by 2 base is 4 into height is here. That is OA is equals to 2. So here 1 by 2 into 4 into 2. 2 cancels, so we get here 4. So we write here 1 by 2 into 4 into 2. Next we find here the area bounded by the line here y is equals to 0, y is equals to 3, and this curve. So integration 0 to 3 x of curve into dy. So plus integration 0 to 3 x of curve into dy. Minus, from this we subtract this area of the triangle, that is PDA or ADP. And here base is 2 and height is this 3 minus 2 1. So minus 1 by 2 into 2 into 1. So right here minus 1 by 2 into 2 into 1. And then we solve this. So here 2 cancel, here 4, here 2 cancel, minus 1, 4 minus 1, so right here 3, plus integration 0 to 3 x into dy. We find x from the equations of the curve, and this is the equations of the curve. From this we find x is equals to y minus 2 whole square plus 1. So we write here y minus 2 whole square plus 1 into dy, which is equals to here this 3 as it is. Plus we find here integrations of y minus 2 whole square. We use here formula x to the power n, n plus 1 upon n plus 1. Similarly, y minus 2 to the power 3 upon 3. Plus integrations 1 into dy, that is y, within limit 0 to 3. Therefore, this 3 as it is, upper limit minus lower limit, 3 minus 2, that is 1, 1 to the power 3, 1 by 3. So right here 1 by 3. Here put upper limit 3, so right here 3. Minus lower limit, we put here 0. 0 minus 2 minus 2 minus 2 to the power 3 minus 8 by 3, negative positive plus 8 by 3. Next we put here 0, so we get 0. Is equals to this 3 as it is. 1 by 3 plus 8 by 3, 9 by 3, that is 3. 3 plus 3, 6. So right here 6. And 6 plus 3, 9. 9 square unit is the required area. Here B is the correct option. That is 9 square unit. So in this way, we solve the third multiple choice questions on applications of definite integration. In this way, we solve the third multiple choice questions. So again, my request, if you like my video, please subscribe my channel. Next, third multiple choice questions. Again, we find here the area bounded by the curve. The parabola's y square is equals to 4x and x square is equals to 4y. Two equations of the parabola is given. This is the equations of the parabola passing through the origin and open towards positive x direction. X square is equals to 4y. Again, this is the equations of the parabola open towards positive y direction and passing through the origin. So the parabola's y square is equals to 4x and x square is equals to 4y. Divide the square region. Divide the square region bounded by the line x is equals to 4 and y is equals to 4. This two line bounded. This two line construct the square region, and this square region divided by this curve into three parts. So the parabola's y square is equals to 4x and x square is equals to 4y. Divide the square region bounded by the line x is equals to 4, y is equals to 4 and the coordinate axis. If S1, S2, S3 are respectively the areas of these parts, number from top to bottom. Top to bottom. Then S1 is to S2 is to S3. We find here the ratio of the areas. S1 is to S2 is to S3 is option A, 1 is to 2 is to 1. Option B, 1 is to 2 is to 3. Option C, 2 is to 1 is to 2. Option D, 1 is to 1 is to 1. But find this area. So first we draw here the parabolas. First parabola, here first parabola is given by square is equals to 4x, that is open towards positive x direction. X square is equals to 4y, open towards positive y direction. Then we draw the line x is equals to 4, y is equals to 4. We roughly sketch this figure. So here we draw, this is the parabola y square is equals to 4x. That is open towards positive x direction. This is the parabola x square is equals to 4y. Next we draw the line x is equals to 4. This is the line x is equals to 4 here. And this is the line y is equals to 4. And this parabola divide the square region. Square region is this O to up to this and this point up to and this point. This is a square region. And this square region divide the two parabola into three parts from top to bottom, that is S1, S2, S3, and we find the ratio of these areas, that is S1 is to S2, S2, S3. By find this. So from this figure, it is clear that S1 and S3 are equal. S1 and S3 are equal because here from this figure, this area S1 and this area S2 is equal. So S1 is equals to S3, which is equals to integration 0 to 4, 0 to 4, and a y of this lower curve, y of this lower curve, because we find here S3. So here S1 is equals to S3 and S3 is equals to integration 0. This is the lower limit, that is the equations of the y-axis, and this is the upper limit, that is x is equals to 4. So S1 equals to S3, which is equals to integration lower limit 0 to upper limit 4, and here y of this curve, that is x square by 4. Y of this curve x square by 4. So we write this here. Integration 0 to 4 x square by 4 into dx. So this is S1 equals to S3. And then we evaluate this integration. This 1 by 4 is constant. Integrations of x square into dx. X to the power 3 upon 3. And x to the power 3 upon 3 into 4. X to the power 12. Because here x square by 3 upon 4. 4 into 3, 12. So x cube by 12. Again, we repeat this. This 1 by 4 is constant. integrations of x square, x cubed by 3, and 3 into 4, 12. So x cubed by 12 within limit 0 to 4. So first we put here upper limit 4 cube. 4 cube, that is here. 4 into 4. 4 into 4 into 4 upon 12. By solve this, we get 16 by 3 square unit. Next, we find here S2. Next, we find here S2. This is S2. That is the area bounded by the two parabolas. This is the upper parabola and this is here lower parabola. Again, limit is same. So S2 is equals to integration x is equals to 0 to x is equals to 4. Y of upper curve. Y of upper curve. And equations of upper curve is this. Y square is equals to 4x. Therefore, y is equals to 2 root x. Minus y of lower curve. And y of lower curve x square by 4. So right here, S2 is equals to integration 0 to 4. Y of upper curve. Y of upper curve. Again, this is the equations of the upper curve. And y is equals to 2 root x. So right here, 2 root x minus y of lower curve, and equations of this lower curve is x square is equals to 4y. From this we find y x square by 4. So we write here x square by 4 into dx, and then we evaluate this. So here 2 as it is, 2 as it is, under root x to the power half. Use here formula integration x to the power n into dx, x to the power n plus 1 upon n plus 1. Similarly, x to the power half plus 1, x to the power 3 by 2 upon 3 by 2. So x to the power 3 by 2 upon 3 by 2. Minus here, this 1 by 4 as it is, x cubed by 3 and 4 into 3, 12. So x cubed by 12 within limit 0 to 4. And then upper limit minus lower limit. First we put here upper limit. If we put lower limit, then we get 0. So first we put here upper limit. Here 4 to the power 3 by 2. 4 to the power 3 by 2. That is here 2 to the power 2 to the power 3 by 2. 2 to cancel 2 to the power 3 and 2 to the power 3, that is 8. 8 into 2, 16. 16 into 2 by 3. After taking reciprocal. So we get here this. That is 4 by 3 into 8 minus here 16 by 3. If I solve this, so we get again 16 by 3 square unit. Means here S1 is 16 by 3, S2 is 16 by 3, S3 is again 16 by 3. That is S1 is to S2 is to S3. That is 16 by 3 is to 16 by 3 is to 16 by 3. Then divided or multiply both sides by 3 by 16. So we get 1 is to 1 is to 1. So here D is the correct option. That is 1 is to 1 is to 1. D is the correct options. So in this way, we solve the third multiple choice questions on applications of definite integration. So again, my request you, if you like my video, please subscribe my channel.